What's up everybody, and welcome to another welding video. Today is Thursday, I think, and in the past couple of weeks you guys have seen a lot of us dealing with titanium and stainless steel and different stainless steels and everything else and mild steels and stuff like that, and I've kind of explained a lot of that over time. So today what I figured we would do is get into a little bit of aluminum. We haven't done much of that, so I wanted to kind of show you guys a little bit about, you know, from kind of an unprofessional standpoint, or I should say a non-classically educated welder standpoint on welding aluminum and some of the differences, some of the quirks, some of the little things you have to watch out for when you first start doing it. Funny little story. When I first started TIG welding was probably about 3 years ago now. I've been trying to figure out when exactly I started, and I think it was 3 years ago or so. I could not, for the life of me, weld stainless steel. I had absolutely no idea what I was doing. I blew holes in every single thing that I welded. I could not get any coloration. I was over temperature, over heat, over voltage, over current. I just could not, for the life of me, weld. However, I set the machine to AC and I started welding on a chunk of aluminum. And funny enough, I was digging through my scrap bin the other day, and I found the very piece of aluminum that I started welding on. This was the very first piece that I started welding. And this was what I learned on aluminum. And you can see there is some pretty nasty, nasty beads on there. There's a bunch of crap that I did. I think this one wasn't clean and it got all messed up. And then I was trying to weld that together and caused all kinds of problems. But the funny thing about aluminum versus stainless steel was that I could actually get it to weld together. Now, I've heard so many people say, stainless steel is super easy for me, but I cannot do aluminum. So we're gonna go over a little bit of the tips and tricks with aluminum that you guys might not know. And what I'm gonna try to do is I'm gonna attempt, I don't know how well this is gonna work, but I'm gonna attempt to use the GoPro and put a welding shield over top of it to see if we can get some puddle shots. I don't know that we're going to be able to, because the way it focuses when it's trying to focus on the darkened stuff, but we'll see what happens anyhow. So what we're gonna do is we're gonna weld probably these two pieces of pipe together, and then we're gonna do a little bit of flat stock also. I think this is just basically some 1/8 inch thick aluminum plate that I use for making like fuel cells and catch cans and stuff like that. So we're going to do that. But the first thing I want to talk about is welding aluminum requires a TIG welder for the most part to do it well. You can do it with a MIG welder and a spool gun, but you're never going to get the same quality of weld that you can get off of a TIG welder. Now the reason being is because a MIG welder can only supply DC voltage. It cannot supply AC voltage. Now AC voltage in aluminum is actually quite important, and we could sit here for hours and go into why it's ultra important, but I will give you the quick and dirty. I'm currently peeling the coating off of this aluminum to show you guys. Now aluminum, if I can ever get this off of here, yeah, here we go. Alright, aluminum, albeit looks very shiny, super clean. Of course it wants to focus on my face, so we'll just wear this like an aluminum mustache. But you can see how shiny that looks. Now, even though that looks super, super shiny, there is a layer of oxidation on this aluminum. As soon as aluminum hits oxygen, it oxidizes. It forms an oxidation layer over the top of it, which stops the rest of the metal from corroding via the elements. So you have an oxidation layer on top of the aluminum that protects it from corroding. That's why it has excellent anti-rust and anti-corrosion properties, is because it actually forms its own protection layer. Now when you weld this stuff, unfortunately the oxidation layer melts at a much higher temperature than the actual metal itself. And this is where you can run into problems when welding this metal. Is you need, I think it's roughly 3,000 degrees, 3,200 degrees to melt through the oxidation layer, and the metal itself melts at about 1,800. So you could potentially overheat this metal, never get through the oxidation layer, and the metal just disappears. It literally just falls out and you can't do anything about it. So you have to be super careful. Now, when welding aluminum with a TIG welder, it's obviously going to be set to AC. Now the best part about a TIG welder is it's got a function called AC balance. Now AC balance, again, something that we could get into and go on about for hours and hours and hours, but for the beginner, your AC balance level, just so you're aware, should be set at about 30 or 70 depending on your machine. Some machines are 30% cleaning, some machines are 70% not cleaning, so it's a setting you have to determine based on your machine. Are we still in focus? Yeah, we're still in focus. All right, so what's going to have to happen now is that our machine is going to have to figure out a way to punch through this oxidation layer. Now, by punching through this oxidation layer, we expose the metal underneath to actually weld. So the machine will actually hold the voltage in a positive location for X amount of time based upon what your balance control is set at. So if it's set at, let's say, 30, which means 30% cleaning action, that means that basically the AC waveform, which looks like a sinusoidal waveform, 30% of the positive is in positive and the other 70% is negative, electronegative. So what happens is when your voltage swings into the positive location, it only swings to 30% and then swings down in that lower section, the negative section will swing down to 70%. So now you can vary that depending on how dirty your aluminum is or how not dirty it is, but a good rule of thumb is 30% cleaning action right off the rip is going to get you the best results for starting. Now once you punch through that oxidation layer, then you need to start welding. You need to start adding filler wire. And unlike stainless steel, aluminum requires a ton of filler wire. Where stainless steel, you can literally take your stainless steel rod and just dab, 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 dab. With aluminum, a lot of times you end up literally feeding. Every time you dab, you feed a good amount of rod in there, because you have to remember, you are punching through that oxidation layer. You're heating up that metal hotter than it's meant to be heated up. So you need to replace it with more metal to, one, cool it down a little bit, and two, make up for the oxidation layer that's now gone and everything else. So when you see a piece of aluminum that's welded and you see the weld bead, and on the outside of that weld bead, and I'll show you when we weld this stuff, on the outside of that weld bead, you guys will actually see the white stripes that run alongside of it. Well, that's the machine, the welding machine, the TIG welding machine, actually punching through and cleaning that oxidation layer. So the white is actually the cleaning action itself, which obviously you could take a wire brush and just clean that up and you're good. So I think what we're going to do is, now that I've explained that a little bit, it's as simple as I can get. Like I said, this video would be 3 hours long if I tried to explain every last little nuance about how the machine is set up and what the cleaning action does and everything else. All you need to know as a beginner is that the machine, if it has the adjustment, needs to be set to 30% cleaning action. Now, some of the machines like my Miller Diversion 185 that I had, it was preset from the factory and you couldn't change it, and it was preset at 30%. So, good rule of thumb. My Everlast, however, I can set whatever cleaning action I want. But what we're going to do is we're going to weld a few of these pieces together. I'm hopefully going to get some arc shots for you guys. I'm going to run through that now and see if we can actually do that and see if it actually comes out halfway decent. And then we'll weld up some beads. I'll show you what the effect of the cleaning action is on the metal. I'll show you what can happen if you overheat the metal, and we'll do that. So let's get to that now. I'm going to set the GoPro up, bring you guys down, and let's weld some stuff. Alright guys, I hope that shot worked out well and you could see enough. I know it's a little tough with trying to get a camera to focus on it, but here's a couple examples of what I was talking about. This is without using any filler wire, getting the metal too hot, and literally the metal just goes away. Now it didn't drip down inside of there. There's nothing inside of there. The metal just receded on itself, and that's pretty common. Now the second thing I was talking about, the cleaning action, that is me using low amperage, and you can see the color, that whiteness that happens is actually the burned up remnants of the oxidation layer that was on the aluminum. That is what you have to burn through first in order to actually get a clean puddle that looks like that. And over the next 10 minutes or so, that puddle will actually oxidize once this metal cools down. Now, just to show you guys something interesting, if this thing will focus, there we go, there you go, is we did that small bead, which these pieces of metal are not cleaned, and we'll explain that in a minute. We did that small bead, and these beads are a little high because I kind of wanted to show you guys. And we did that small bead. Now with those 3 small beads, that's all I have left of a 3-foot long filler rod. So you can see how much material it actually takes to weld something that is not fit up well and has a bit of a gap. It takes a lot of aluminum versus doing stainless steel or titanium or anything else where you can just dab, dab, dab. Each one of these little dabs right in here, each one of those little ridges is me literally feeding in that much wire. So an inch of wire, half, well, maybe about 3/4 of an inch of wire per dab, just to get that gap filled in. So yeah, way different from stainless steel, way different from titanium. Alright, so now hopefully you got some decent arc shots. I'm going to do another one where I'm going to weld this piece to that piece, and we're going to do kind of like a lap joint, and we'll see what we can do for dimes on that one. Alright guys, so I'm hoping that these arc shots came out good. I don't know what they're going to look like yet. I'm going to have to edit them a little bit in post, but I think they'll come out somewhat decent, and if not, I'm going to have to mess with the setup a little bit, but try to get you guys in a little bit closer. So anyway, let's talk about some of the weird quirks of aluminum. Number 1, it handles heat very weird. Everybody's always told you throughout your life that aluminum is a great heat sink, and it really is. And the reason why they call it a heat sink is because it absorbs heat very rapidly and can also dissipate it fairly well, but it is designed to absorb heat, and then you need a shit ton of surface area to get rid of that heat. Hence why a heat sink is finned, because if it was just a solid chunk of aluminum, the only surface area you have, let's just say that this was aluminum and this was your heat sink. Well, the only surface area you have to get rid of the heat is here. Assuming your heat source is coming from behind, your heat is going to be right here, and there's nothing to get rid of it. Now, if you cut slots in this, the added surface area of all those fins will allow the heat to dissipate much quicker than it could if it was just a solid block. Now, what does this mean when you're welding it? Well, when you're welding it, it absorbs heat very, very quickly, which means the part gets hot very, very quickly. The heat in the part is constantly changing while you're welding it. So you will start in one pedal position. Let's just say, like with these flat plates that I just did, it was 120 amps to get these things to puddle. Now, mind you, on the stainless steel and the titanium, we were using 35 to 40 amps. And it just took us on material that is only about 1.5 times as thick. So we would normally need 60 or 70 amps. It took 120 amps to puddle this stuff. By the time I got to the end of the bead, we were only at about 40 or 50 amps. So that can tell you how much heat this stuff absorbs. So every subsequent weld thereafter is only going to need 90 amps to get the bead started, 80 amps to get the bead started, 70 amps to get the bead started. And where you can make a mistake really, really fast is thinking that you need that full 120 amps to get the bead started again, to get the puddle started, and you'll blow a hole in the metal. So I'm going to show you guys now up close with this camera some of the different types of beads and the different heat ranges, and I'm going to also show you what happens when you put too much heat in, when you put not enough heat in, when you don't modulate your heat properly with aluminum. I'll show you a bunch of beads like that, and then I'll show you a bead that was done properly. And I accentuated all this stuff so you guys could see it, because it's kind of hard to see on camera. So I made sure that I accentuated it. So these beads are going to be raised a little more than I like, but it is literally just to be able to show you guys. So let me flip the camera around and I will show you down on some of these welds that we did. Alright, so here we go. This is the first piece we did. Now you'll see that this bead is super, super fat. This one was welded with too much heat in the beginning, therefore it's very, very wide, very fat. And then as we move down the bead, you can see it change significantly. You see to where you're losing that dime effect, and it's just starting to look like a pond of melted metal. That was me keeping a consistent 120 amps all the way to the end. And if you can see right there, there's a huge crater at the end of this weld, which is something you don't want. And you also see that the puddle started to fan out a little bit. That is also something that you do not want, is that puddle to fan out from where you started. So then we flipped over this piece and we did something again. We started out at a much lower amperage. We barely got it to connect the puddle there. And then we were moving, and we started to get a good pattern right in the middle right here. And then I kept on the pedal at the same amperage and we washed out again. And this is what you're looking at. Now you look on this side, that was the weld I just showed you guys on the side before with too much heat. You can actually see it penetrated through the bottom of this part, which again, not good. You want it to penetrate so that your weld is penetrated into the metal properly, but you do not want that metal falling through itself, which is what it did right there. So there's two examples of not right. Now, 3 and 4. This weld, a little bit less heat, a little bit thicker filler rod. Again, puddle all over the place. Everything's all over the place. We had too much heat in the part. The bead was jumping outwards. It fanned out at the end. Again, this piece was hot now. We're only running about 60 amps. And you can see how uncontrollable that bead was. Here, less amperage, too little. You can see that there is a space. Let me see if I can get something better to point with. There we go. There's a space right here where there's no weld metal, and the weld metal sucked back beyond itself. We didn't have enough heat here to actually burn into this metal, and you can see evidence of that with the cleaning action. Here's your cleaning action right here. You see that you lose it almost completely by right here, and then we added too much heat in here and ended up with more washed out puddle. So now let me show you what a good weld looks like. So again, this bead is accentuated so that you could see it. So we started out with a thicker filler rod. We started here. The part was still super, super hot, so we had to back off the heat real quick because that bead was getting too big. And then as you go down the bead, you can see the white stripes on either side, the cleaning action. We were exactly where we needed to be. We had exactly enough filler metal. We had exactly enough penetration. And at the end, we didn't have a crater. Now, it is super important when you end an aluminum weld to dab in a little extra filler rod and back off of your heat and your pedal very, very slowly. Otherwise, you'll end up with a big crater in it. Alright, so for the sake of this video not being blurry, hello, there we are. Alright, for the sake of this video not being an hour and a half long, aluminum's quirky. You can definitely do it. You need AC from a TIG machine, you need to have patience with it, and you need to learn foot pedal control. So my advice to you is get some scrap aluminum plate. don't try it on tube. Tube is very hard to weld at first. Try some aluminum plate. The thicker the better, because then you're less apt to burn through it and you'll get an idea of how to control your heat better. Aluminum is definitely a lesson in foot pedal control. You really need to have good control over that foot pedal to get a nice, even, consistent bead where you're not destroying the metal. So let's go over the basics of doing a clean aluminum weld. Number one, good fit up. I can't stress this enough with any metal. The better the fit, the easier it's going to be to weld. So if you're cutting two pieces of pipe and there's an 1/8 inch gap in between them, you're going to have trouble. If they're butted right up against, they're much easier to weld. So good fit up, that's number one. Number two is cleanliness. I did it off camera, you guys didn't see it. I didn't do it on the piece of pipe, but I did it on these plates. Acetone. Wipe aluminum down with acetone. You can even hit it with a stainless steel wire brush, which will help get some of the oxidation off of it before you actually weld it. But in most cases, a good acetone bath and a little extra heating with the cleaning action before you ramp full into the pedal is going to be good. Number three, speed and heat control. Speed and feed, basically. For anybody who's a machinist, you know about speeds and feeds. Same goes. You have to turn yourself into basically a CNC machine. You have to coordinate your right or left hand with the torch, your right or left hand with your filler wire, and then also your right or left foot with the foot pedal. And all that needs to happen in concert so that you can actually get a weld that is consistent. You can control your heat, you can get enough filler metal in there, and you can create, you know, that look, that effect of dimes that, you know, everybody's always looking for. So practice is going to be the number one key on this. Now, welding mild steels and stainless steel and everything else still needs to be clean, but you can get away with a lot more with steels than you can with aluminum. Aluminum is very tricky. But my advice to you guys, the way that I weld is I get it to puddle. Once it puddles, I add filler immediately and I run with it. Now, I will literally light up on the surface, give it about 2 seconds for the cleaning action to blow away some of that oxidation. I'll go full pedal, get it to puddle, back off the pedal just a hair, start adding filler metal immediately, and then start moving. Just start moving. And the faster you move, as long as your heat is good, you will get the larger dime effect, the shorter dime effect, the tighter ones, the looser ones, whatever it is that you're looking for. That's how you're going to do that. But so anyway, I hope you guys enjoyed the hell out of this video. I had a great time making it. Try to get more welding stuff to you guys. I know I can't always be doing projects because I'm not always doing projects, but if I can give you little videos like this that'll maybe teach you about TIG welding, something like that, then that's what I'm going to do. So hope you enjoyed the video. Please like, comment, subscribe. Leave me a comment down below on, you know, what you want to see more of, what you don't want to see more of. I know you guys like the longer videos, so here's one for you. I hope these arc shots really helped out. I know a lot of you guys have been asking for that, so thank you again for subscribing. Thank you again for watching, and I will see you guys on the next one. Have a good night.